everyone. Thank you for coming. So today we'll have our fourth lecture on Python. All right. So we started working on the basics of the Python. So in the last lecture we spoke about the containers. Okay, the containers. So we explained what are lists, right? And then tuple thing, strings, dictionaries, right? And maybe we started with numbers, although they are not dictionaries. Date plus time, right? That's what we covered last time. All right. So these are containers. Okay, the list, for example, to create a list, you're going to have the square bracket, tuple is the round brackets, strings, quotes, and dictionary is the curly brackets, right? And we said to reference any of these, always we're going to have what? The curly brackets, right? Also, we learned about two terms last time, which is like mutable and immutable. Okay, containers. So, for example, lists are immutable, right? Tuple are immutable, and lists are immutable. That means you could change lists, but you can't change the tuples, right? Right? And we learn how to iterate through them, how to use them, how they occupy the memory. And I'm sure you had a very good homework that you have been working on it. Anybody has a problem with the homework? All good? Okay, that's good. All right. So when you look at the Python, we're speaking so far the basic language of Python. We spoke before about how to create the variables, how to define the functions, how to call the main function, how to call functions for the main functions. We spoke also about methods, okay, functions, most methods, okay. So what we are trying to do in this class? What are we trying to do in this class? So in any application in the Python, it has kind of three boxes. It has kind of three boxes. It has three boxes, all right? So far we were working on the front end programming, right? Right? And there is something called back end programming, and there's the display. All right. So in the front end, we've spoken about the basic language, how to use the controls. So what we covered in here, the variables, okay, the controls, functions, okay. And what's remaining? What's remaining that we have to talk about?
Classes.
Okay, object-oriented programming, which includes classes, okay, object-oriented programming, all right, and other stuff, including GUI, for example, graphical interface, okay, and etc. Right. So when you talk about the back end, what do you have in the back end?
The code, the logic.
The connection.
Huh?
Connection?
No. So where does the data come from?
Servers.
Huh? Server?
Servers.
What kind of server?
Databases.
So where is the data? Usually the data could be like files. Okay. The files could be ASCII files, or it could be binary files, as we'll see. Or it comes from database, right? The database could be SQL,
MySQL.
NoSQL, okay, different kind of database, right? In the previous examples, in the previous lectures, when we were trying to create the movie application, where is the data coming from? Where did we store the data?
List.
In a list.
List.
In a list. Is that reasonable? Is that how real applications work?
No.
You keep it in a list, right? You have to get it from somewhere. The data has to be saved somewhere and brought to the program somewhere. Okay? So there's an interface in here. So the data, okay, could be write or read, right? So the data has to be mined, has to be stored somewhere. It could be a full-fledged database. We're going to learn about how to connect the database, or as we're going to learn today, in input-output files. Could be digital files, binary files, ASCII files, text files, okay, stored there, right? So technically, in our program, let's say we have the one we practiced last time, the one we practiced. If you enter like 50 movies, okay, and you close the program, where is the 50 movies?
In the list.
In the list. Where is the list? In the memory. And if you shut down the program, what happened to the list?
It's gone.
It's gone. So it does not make any sense, right? But starting from today, we're going to read it from files, all right? In a few lectures, we're going to read it and write it to where? The
Files.
Database. So you'll learn how to read, write to files today. In a few lectures, you'll learn how to read, write to database. You'll be able to create a database, right? So data is in here. We're going to create a file, today binary or ASCII that has the movies, the information we need about movies. And our program, what is the first thing you're going to do? Open the file, read the data, and do the processing, whatever the processing is needed, and write back to where? To the file. Where is the file stored?
In the
On
memory.
disk drive. Nothing will change. If you try to fetch the data again next week, it's there for you. Okay, so what we'll do is having like physical files, whether they are binary or is it practical? Yes and no. It's very simple. For a small application, it's very simple. But when you're talking about records that has millions of records, okay, where are you going to save them? In database. So we have to learn how to connect our program, which is like the brain, to where? To the database. We're going to fetch the data. Now, when we have the data, what are we going to do with the data?
Process the data.
The process the data. Now we have the data. So for example, okay, it's a canvas. Let's say this application is a canvas. And I need to fetch, for example, the students attending this class, taking this class. All right, then what are they going to do with it?
Make sense of the data. How many students are coming? How many are absent?
Okay, all right. Sometimes the obvious answer is not the answer. Most of the time, the obvious answer is the answer. Unfortunately, it's not the answer here. What you do with the data, you display it, right? So far in our application, where we display the data?
On the terminal or the
In
screen?
the terminal, so we'll display it display it. So console. All right? What other forms of display? We're going to learn about view. Okay?
Mhm.
View, okay? All right, what other form of display? What is the most common one?
The screen monitor.
View it on the screen, right? And the console on the screen. Are you sleeping, guys? Right? So, by the way, the only thing you could watch in your laptops is my lecture. If you are doing something else, please don't. Okay? All right? So,
On websites?
thank you. Okay? We're gonna display it. So any application. Now, what do you have it? You're gonna have it now. What is the most common things? Every application you could read it where? In the web. Also where? Mobile app, the Kiwi. Or in the console, like an application we have. So in this class, you're gonna learn all of these. You're gonna learn how to create a web page. Okay? How you connect to the web page through the application you're gonna write. So what you're gonna put in the web page? You're gonna get it from where? From the back-end database which you're gonna create, right? Or from files, right? Or you're gonna display it where? in the display. So you will create like a mobile app, and you will create a www page, and you already work in a console, right? So you display all of that, right? So this is the engine, okay? The engine takes from in here and sends where? To where?
To the display.
To the display. The display has forms. Like when you fill the forms, request, where it goes? It goes to the database, or it goes to here? And from here it goes there. Right? So let's say that you need to know Mr. Shah what class is having. So you see the request in here, your canvas, here, the canvas. So it's gonna go where? It's gonna go to the program. The program which runs, like it runs, it's gonna connect where? To the database. The database will answer the question, the request. It will set the data. Okay? The data could go this way, or it could go directly. It could go directly. Okay? To the display. The same thing with the GUI. Like a mobile app mostly now, right? Or even an application. You could create an application, right? A normal application. Right? So that's what it's doing. Okay? So for that, for this class, we need to learn the variables, the controls, the functions, object-oriented programming, which is a big deal. Okay? The GUI, and for display, we need to be able to display our data. Where?
On the website or on the screen?
We already did. Right, the print. GUI, we did not take it yet. Website. Alright? And you need to, this is sometimes, do you hear me guys? It's good? Right? So, and the data gonna come from where? Database. So all of you know how to do databases, right? You took database class before, right? So you know SQL? Who does not know SQL? 1, 2, okay. Alright. Sorry I asked. Alright, so we'll learn basic SQL. I'll give you some handouts, okay? Because there is a language, how to process the data, how to store the data, right? And by the way, that will be your project, more or less. That's your project. So your project is to create a whole system using Python. Okay? Using Python. Okay, that's what we'll be doing. Alright? The only thing is different now. I don't know yet. What is the application I'm going to ask you to do? So I might ask you to create Canvas. So for that, you're gonna download SQL, right? What we decided to do SQL, right? Or Canvas, or any other. I'm okay. Oracle, any other Canvas. You're gonna download it. You're gonna create your tables. All right. I'm gonna teach you a little bit about how to create web pages from Canvas, right? Okay. And you're really learning the language. We're gonna talk a lot about object-oriented programming. Right? Maybe if we have time, we'll teach you a little bit how to create mobile app, right? You're working on that, right? Mobile app, simple things, even simple, like reading a few numbers and sending few requests, okay? All right, it could be complex, right? It could be a whole course and all of that, and all with Python and through different tools, okay? And that will be your project. This project, you're gonna work as a group, all right, as a group, and this project that you need to work very hard to pass this class and to keep it in your computer on a flash or on a flash disk. When you go for an interview, you show them your work, or even in a phone interview. This, even before you finish your degree, if you manage to have a very good application from A to Z you design, will get you a job. All right, that's how it is. All right, you have. I mean, you could learn bits here and there. It makes you. It's very good. I mean, it's not bad. But when you present a whole project like that to your employer, okay, it makes you feel good, right? So until now, I've not decided what kind of application. Canvas came to my mind. You're going to keep it open for you also. So if you are interested, for example, in a certain application that you want to do, as a whole, like that. You're doing sports, right? Yeah. So maybe you need to have an application related to sports, right? Okay. So maybe you are a businessman, right? So maybe you need to have something for your cow farm or something. Okay, whatever application, all right? Somebody's farmer said, I have no problem, and look, it's a comprehensive. We'll think about it later. But you're going to employ all of these technologies and not simple technologies. is gonna take a big part from you in educating yourself and learning and try things out, all right? That's why I recommended you to work in groups. I don't want you to stuck working by yourself. It becomes very boring. It's very interesting, not boring, but when you work with a partner and divide the job. So if you don't know SQL, all right, my friend, today, this week, why don't you work in SQL, learn the basics of SQL, creating the database. I'll work, for example, in how to develop like the mobile app. You did mobile app, right? In the project we did together, right? We traveled to, she won third place in a competition. And the thing you learned during the project yourself, you're doing it with your friend, the mobile app. Your friend, not you. What was your part? What was your part?
Web page.
The application. Okay. So there was a group of 3 people. They were creating IoT, application competition. Went to New Mexico. One person worked in the hardware, so that helped a lot. One person in the mobile app. One person in the database of the application. It was a good work. A lot of work. That's how it is. Always think of like your work when you graduate from here. That you are not going to open your own business right away. Maybe you will. But if you go work anywhere, you're gonna work in a group, in teams, and you are given a portion of the project. So you have to learn how to work with other people very well. You have to know how to divide the job. You have to learn how to receive and do some work and submit. Okay, that's how it is. You have to learn, and this is the right time here. How to choose a partner. I always tell my son when he goes at the beginning of the year. That when he was listening to me much. All right. So I used to tell him when you go to school, the first day in school, you have to be like an eagle. Look very well. Where people, catch them, stick to them. Okay. Always stick to the people who work very hard, very smart, because you're gonna do project. If you partner with a person who does not know anything, okay, will make you know very little. Okay, you both will learn, but if you work with somebody, he's very hardworking, and you could produce a lot. All right, and that's what. And picking a member or a team is a talent by itself. Talent. You look around in here, okay, see people how they ask good questions, especially the people sitting in the back there, they look what everybody is doing. So if you see this person is like YouTubing or doing something right now, don't partner with him. Use this, okay? But to see that person, while I'm teaching a code, is writing it, trying it out, trying different things. This is a serious person. Okay, right away approach him. Can I partner with you? All right? Okay, can we work together? There's nothing wrong with it. Always stick to the smart people. Okay, smart people, hardworking people. Okay? They win and you win. It's a nice win-win situation. All right, so having a partner, okay, in work. I'm not talking on life, by the way. Here, it's a different thing in life. I'm talking about work. All right, having a partner is a talent. It's a talent. It's to know who you should work with. And by the way, it's a talent also to know when to quit. So you start to work with some member, some colleague. After 2 weeks, is not going to make it. Okay. It's good to get divorced right there, right away, all right? Work by yourself or find somebody else, all right? Sometimes it's good to work by yourself, better than work with somebody that make you sick, okay, to produce. So I would like to develop this talent now, okay, while you're doing your courses. Not only in my class, every course. And that's why we try every course to give projects, okay? It's not only doing the project, it's the whole process. Anyways, going back to the project. So we are going nicely. So far we are covering a lot of stuff in here. All right, we're gonna next week talk about object-oriented programming. Then we're gonna talk about GUI. Then we'll talk, I'm not sure whether, there's a lot of things, okay? But it will be very condensed. I'll cover whatever I can cover. But that's what I'm looking for, okay? So knowing that, if you are like active student and, forthcoming student, so you know that you'll be working in, for example, in a database. So if you do not have database, start looking at videos or learning a little bit basics of database, SQL, okay, because, you're gonna work in, for example, web development, Well, if you don't know HTML, try to go over HTML, very simple, very easy, okay? Of course, I'm not expecting that you'll have the most fancy application here, but I need an application works. Clear? Deal? That's number one. All I said is number one. Number two, there is a lot of sources and resources available for you. So I cannot tell you cannot cut and paste and use other codes from the internet. Can I tell you that? Even if I can tell you that, or if I tell you that, I don't know how to make it happen, right? Right? So you could do whatever you want, all right? You could borrow a code, you could steal a code, you could buy a code, you could do whatever, okay? Be my guest, even in the homework, be my guest, because I cannot, check it out. I cannot know, okay? The only way to check it out is to put you in a closed room, until you write the code. Then I know you did it, you know what you're doing, right? You don't have time for that, I don't have time for that, okay? And I don't care also about that. But what will happen when you start submitting the projects, okay? You wrote the project, this is a project. The submission of the project is going to take 1 hour per group, okay? So when you submit the project working, I tell you, thank you so much, it's working. So I needed to go now to the front end, I needed to change this and this and this to work like this and this and this. I need to go to the database. I needed to populate the database or remove things from the database or add a column or add attribute to the database in the spot. All right? I needed to go to the GUI, the application you created in the mobile app if you created one, and I needed to the application to look a little bit different. You have 5 minutes to do it. All right? So if you are the group or the members of a group did the work, okay, will you be able to do it? The answer is, I need to hear it. Yes, all right? If otherwise, will you be able to do it?
No.
Maybe yes, maybe no. I don't know, okay? So that's the way you will be judged, okay? Even the final exam, it most likely it will be like a program that will ask you to write. With no internet, with anything in the lab, I'll take you in the lab, there will be no internet, so you cannot even have access. Maybe you will have, I don't know, depends how difficult the program. I'll ask you to write the code. I'll give you a problem, write the code. Here you go, write the code. If you were the person writing the code and trying hard to understand how code work, how commands work, how control, how object-oriented work, will you be able to write it? Yes. Why yes? Because I give you a reasonable question. Okay? If I give you time for 1 hour, I know an average student will be able to do it or do most of it. Right? If you don't, that means that you were doing something else. Right? So, until then, you could do the something else, but I'll catch you later. Alright? Catch you. Alright? My goal in this class is, not to, to accommodate weak students. My goal and my aim is to make weak students the best students in the class, which happens all the time. Usually the people start the class with no knowledge become the most knowledgeable. You know why? Because they are challenged. And they want it to be. Alright? That's my goal, that's my aim. Alright? So please make sure, and I wanted to talk about the project right now, not usually I talk about the project later. And the last, the last month of the semester, last 4 weeks, we'll just start doing it. Now I'm telling you in advance what you'll be doing. Okay, it's a lot of work, a lot of things that you need to work and practice, okay? And you'll enjoy it. You'll enjoy it. Just think of application that makes you happy, all right? And all these components will be there. Okay, you'll be very proud of yourself at the end of the semester. If you are able to do it, wouldn't you be proud? I'm sure you'll be proud. Okay, so that's what you'll be happy. Did I talk too much already? I think I did. So we'll continue today. So as I told you, as you see, we're covering a lot of stuff. So today we'll cover 2 things, or 3 things actually. We'll cover the I/O, input output to files. All right. Then we'll cover something very important, which is exceptions. And then we'll cover recursion. We'll see some of the algorithms for that. So it's an easy lecture today. Hopefully we'll finish earlier than usual. It doesn't happen, but let's hope for the best. All right. Any questions? I forgot to mention that some of you are undergrad students, so I expect little bit less from undergrad. Let me put it in a different way. I expect much more from the grad students, all right? All right, so graduate students will be asked to do more than the undergrad. So figure out how to make undergrad UG students happier than GR students. Okay, so to be fair, I mean, okay, but you know, because shall I tell you why I said that?
Yeah.
Shall I explain why I said that?
Yeah.
Very easy. All right. So, all right. So let's make it a contract right now. So, how many of you are full-time students? No. How many of you are not full-time students? Not. So all of you full-time, right? All right. So let me ask you a question. In the United States of America, what makes you a full-timer? How many hours you have to work per week to be a full-time?
40.
That's not the truth.
30, right?
40.
30 to 35. I forgot exactly, but I think it's about 30. If you work for 30 hours, the full-time. Okay? I think it's for example, myself, I don't work for 40 hours in full-time, so 30. I think it's 30, right? So 30 to 35. Let's make it in between 30, right? 33 hours per week. Right? That makes you full-time, which you all full-time. How many courses do graduate students have in here?
3 courses.
3 courses. So if we divide 33 divided by 3 courses, so how many hours
11.
per course? 11 hours. So that's my expectation from you to work for my class. 11 hours. So let's count how we made them. So you come to the class how many hours?
2 hours.
2.5, right? And to come transportation going, half an hour. That will make it 3 hours, right? 3 hours. How much remaining? 8 hours, right? 8 hours. I need you to review the material I'm covering in here for 2 hours. 2 to 3 hours, okay? Let's say 3 hours minus 3 hours. How much are remaining in here? 5. That's for the homework. Okay? And this is for who? For the graduate students, week, average, or advanced?
Everyone.
For the average. 5 hours for the average. So the average is supposed to work, you know, in the homework of the project, 5 hours per week. If you are a weak student, if you are excellent student, you are advanced, you took a class, how many hours you need to do it? Maybe 2, right? If you are a weak student, came weak, you don't have background from different discipline, from TM, from electrical engineering, how many hours? 7 to 8, let's say 8. Okay? So you're supposed to work from 2 to 8 hours, depends on the level you have. It's not my problem that you are weak. I'm not going to give you a discount on your time. You have to pay from your own time to work. And if you are excellent student, you deserve it. Work harder. Okay, doing all of that. So that's what it is. Now, that's really what it is. Now, what is a full-time for undergrad? How many courses?
6 to 7.
6.
6 to 7 classes?
Yeah.
There's no 7 classes. No.
I'm taking 7.
Huh?
I'm taking 7.
You take 7 this class, this 21 credit hours?
No, I mean, well, it's not 21 credit hours, it's 7 classes. But some of them
How
are
many credits you have?
18.
18, that means, divided by 3, how much?
6 classes, but there's
Six.
classes that are 1.
I mean, on my standard is 6. 7 is too much, really. By the way, I finished 5 years of engineering myself in 4 years. All right? And I don't remember, I took 21 credit hours. Okay, because you take it in the summer. So, you know, 6, right? So 3 to 6 should be, like, less time than the graduate. So basically, I should give the graduate student double. I'm not going to give the graduate student double work. I'm going to give the undergrad more work. All right? So that's what it is, to be fair. All right? Okay? So that's the expectation. And this is a senior level class, so you chose to take this. So you're choosing it, okay, means that you're accepting to be here. Are you senior? No? What are you, junior? Junior? Good, close. Close. You know, one more year become senior, right? Okay? Anyways, so please work hard in all the classes you have. It's not only this course, every course, you know, hard working students always are happy. Always are happy. They make themselves happy. All right. I'm not sure what to do. Is it good like this?
Yep.
Nicer like that? Maybe like this? Good? All right. So, all right. So today we're going to talk about as we said, about the IIT, not IIT, I teach IIT, about the I/O. All right. So you know the files. The files usually could be binary, as you see, or text, right? So usually the text, if you open it with the edit, you'll be able to read it as it is. The binary will be a bunch of letters that you cannot read, as you see in here. You agree?
Yes.
All right, so the sequence of file operations. We're talking about files. So in this class, we don't want to save the data in the list. We need to take it from a file, write it back to the file. In the between, we could read it to a list and process it in the list. Anyways, so it will be a permanent storage. All right, for now, it's not the ideal, but we have to deal with files. We have to deal with files, and we have to know how files are working. So basically, what are the sequence of files operations? If you're trying to open a file, and you're trying to work in a Word file, for example, what you do first? So the first thing is you open it, then you write to it, or read. You either open or write, and then what you have to close it. So these are the processes that you need to do. Open, read and write, and then close. So you must do all of that in your process. All right, so to open a file is a very simple thing. What you have to do, open, as you see the method for your the function, open, you give the file and the mode. What are the mode?
Read, write, read, write.
Okay, you could read, you open it for reading, you could open it for writing, you could open it to append to it, or you know, it could be binary, write, read, and append, as we will see later. After you open it, and you have to specify the mode, why you are opening it. You have to tell why you are opening it. Are you opening it to read? Then you put R. To write to it,
W.
okay, you put W, etc. Right? So after that, you have to make sure you close the file. You have to make sure to close the file, okay? And we'll teach you a way that how you automatically close the file. How you automatically close the file. So closing the file is a very important thing, all right? All right, so how we can open a file in write mode and close the file manually, that you have to do that. So you have to do two methods. The first method is open. You have to say open, as you see in here, open. And then you specify that the file is stored in your hard disk drive or somewhere else. It could be like a web link also in here, okay? So, for example, in this case, it's test.txt, and the mode. What is the mode? Write. So I'm opening it to write to it. And in Python, what we are dealing with objects, right? So what is list? Object. What is tuple? Is an object. What is string? Is an object. What is a file?
An object.
Is an object. So we have to, what is an object?
It's a class, a function.
It's an image from a class. We're going to talk about that in object-oriented programming. Okay? But when we create an object, what we do? What do we create it?
An instance.
Reference.
Where?
A reference, like in the memory.
In the memory? You said the memory?
Yeah.
Yeah, the memory, exactly. So when the memory is a big block of locations where you could save data, right? You create data. So how can I recognize this is the file location? I have to give it
The path.
a name. I have to give it a name, object name. So what we did in here, the return of the open, in the open is an object, is saved in out file. What is out file? A name for an object. What is the type of the object? Is a file. All right? So from now on, if I would like to refer to that location, to that object, how would I call it? Out file. Out file. All right? So we should understand the concept of objects, how it works, right? It's a concept, all right? Exactly when we create a list, okay? When we create a list, let me see here. When you create a list, okay? So for example, L underscore 1, 1, 2, 3, 4. What is this?
A list.
A list. Okay, what is saved? In the memory. Okay, it's an object. So L underscore 1 is an object of a list. Whenever I would like to reference that object or refer to it, okay, I'll call the name. What is my name? Shakur. My mom called me Shakur. So the whole word is a memory. My mom, when he issued me in here, gave me a name Shakur. Whenever you need to call me, what do you call me? Shakur, an object, right? Okay, it cannot be more clear like that. So always you try to create an object and give it a name, and from now there we access that name, right? It's a memory. What's that object? Is a place in the memory, right? So in here we have out file is the object. Now from there, now each object you could apply many methods on it from the class. So in here, for example, this is out file. From now on, I gotta use out file. So out file dot write. So what I'm doing now, I'm writing to that object a word test. Okay, out file close. What I'm doing, I'm closing that file or that object of file, right? And exactly that's what we do, right? So we opened it. We give the name for the physical file. We move the physical file to as an object to the object in the program. We gave it a write mode. Then after that, I could write to it. And after I finish, I could have like 20 lines of writing. Then after that, what I do, close it. All right? So this is like manual close. Manual close. All right. So how to use with the statement to open and close files automatically. So instead of using the close sentence, we don't have to do that. What we do, we use the word word. Let me just check if there is different color. So which color guys you like? Because there's a lot of red. How about we use purple? Does it make sense? You agree?
Yep.
Okay. So with. So you start with. Seriously? Yeah, no. So with, okay, with, open the file, the mode as a file. We give it a name. Okay, now we give it a name, that's the object, and then put all the statements. So what will happen? You'll open it, you do the process in the statements, and then automatically what you do, close the file. Automatically close the file. So when you look in here, for example, look at this in here. With open test.txt, I'm opening a file in the hard disk drive called test.txt, and with write mode as out file, I call it the object. I call it out file. Then I say out file.write test. That's it. I don't have to use the close because once I finish the statements, the close will happen. It will be closed, right? In here, what I'm doing in here, the same thing. Open test.txt with read mode, all right? And then I print a whole line to it. I print the whole line. I don't have to use the close. And this is, by the way, the way you should do it. You should use the with statement to make sure that automatically it gets closed. All right. So the write method of a file object is very simple. You could write any string to the file. As you see in here, look in here. So with open, there's a file, and with write mode, write, file, write, and I'm writing John Cleese. Okay, and there is an end of line at the end of that. Right? Also, if I need to append, so when I write to a file, when I open a file as a write, okay, and if there's something on it, it will wipe it off and start from new. If I need to keep the old information, what should I do? Append. I should append. As in here, you see the mode in here? Append. Append. So you append to the file. So now, how many lines I have entered to this file? The first command entered John, please, and the second one entered Eric, idle. So if I go and cat that file or display that file, okay, it will have 2 lines. So in the editor, it will look like that. All right? But the reality, how we write it in the file, you have like the first string and the new line, then the second string and new line. When you do the edit, when you edit the file, it will look like that. Right? Clear? Any questions? Any questions? Okay. All right. There's three methods of a file object. There is read, and there is read, and there's read lines with S, and there's read line, and they work differently. Read the whole file, or read lines, and read lines. So let's take a look how they work. So how we can use a loop to read each line of a file. Okay. Usually when you look at file, the file is built of what? When you look at any file, okay, this is a file. Okay. So for example, it could have like last name, first name, Shakur. Okay, 1992 per date. You believe me, right? Okay. All right. So I'd have many other people. So what we call this in here, what we call this line, right? Right? Or we call it record. Right? And these in here, like this in here and this in here, what we call them? Fields. So fields, right? And the line could have multiple fields. And they could have different number of fields. So one line could have 4, one line could have 3, there's no problem with that. All right? What ends the line? What makes the end of the line? What makes the end of the line? Is the \n, the new line, right? Then a new line starts in here. And what make a field is something separate them. So if what is separating them is a comma, we call it comma separated values. If it's tab separated values. Okay? Or it could be a space. Right? So that's what is file. That's a file, right? That's how data is stored in the file. You agree? Okay, there's nothing special. So what we are doing in here, okay, right, as you see in here, block in here, with open, and we already learned what's the with. We used with, that the file will close automatically after we finish the statements. Okay, with open, okay, with open, okay, in here, so the width, see the width. So we opened it, open the file for line in a file. So print line, and remove the end of line at the line, which is \n. Remove it with nothing. So this is not a space. There's no space. We're removing the end of line, the \n from the end of the line with nothing, and then you print it. Okay, you look through it. All right. The other way to do it is to read the entire file using the read. As you see in here, the read. Okay. The read. It will read the entire file. It will save it where? In contents. What is contents? It's a file object. All right. And then it prints it. You could print it on. Okay. So the results that printed to the console, it will be what is inside the file. All right. So far, what are methods we have learned? Open.
Close.
Okay. With open. Close. Write. Read. Right. Read line. Read lines. Okay. All of these are methods that we could use. How can we read the entire file as a list? Now, usually when you have a file and you need to do processing, I mean, you have to read the file. Let's say that you have a file that has movies. Okay, it has 50 movies, and you need to do processing on it. Whatever the processing, what do you do? You have to read it in your program. Usually, where do you save it?
In the list.
To the list or to a dictionary, depends what you want to do. Usually to a list, right? To a list of lists. To a list of lists. And then you do the processing. Then what you do with the list? You write it back to the file, right? So you import it to a list. So look in here, what we are doing in here, open a file, members.txt as a file. Then what we are doing, we're reading the lines. We're reading the lines into the list. So what I will have, I have lists of lists. List of lists, okay? Then after that I could print, for example, here, member 0, member 1 of the list. All right? How to read the line of the file, one line of the file, the same thing, okay? So I open the file, then member 1, for example, the first line, first file, read line. First time I call read line to read the first line. I call it again to read the second line. Third time, the third line, and so forth of the program. How to read and how to write and read a list of strings. So members, what is members here?
Names.
It's a list. It's names, yes. Members in here is what? It's members of string, right? How many members it has?
2.
2, right? So if I need to save it to a file, how can I write it? So I have to open the file. So what is the name of the file? Members.txt, right? In the right mode, right? And again, the object is file. That's the object that I will use. Now, for in members, so what is the first M? Johnny, please. What the second M? Eric Idle. So I'm iterating, okay? For M in members, file, write, M, and I'm adding a new line to it. So what I'm doing in here, I have a data in the list, I'm reading it, and writing it back to where? To the file. Okay, so we're adding a new line. We're adding a new line. If that file is a file for movies, we are adding one more movie, right? If it's a phone book, we're adding one more entry, and so on and so forth. Clear?
Yep.
All right. So members. So how to read now? How to read the lines in a file into a list? So I have a file, like the movies file we learned before, and I need to read it to the list. So the first thing what I have to do, create an empty list. It's an empty list. So this list, again, I put data inside. Where is it coming from? From the file. Again, I read it from the file. All right? So members, okay, it's empty list. So with open, I open the file. For line in the file, so you're going to read the first line in the file, and then the first thing what we do, we replace the new line with nothing, and then after that we append to the line. Append to the line. What is the line? It's the member of the list. So we append it to the line, and it's the member of the list. Anyways, so it will be added to the list in here. So here removing a new lines from the list.
Sorry, I didn't understand this question.
Should I read this?
Yeah.
Okay.
Isn't the line now is empty?
So, okay. So first of all, we created an empty list. You follow here?
Yeah.
Empty list that we're gonna take the data from the file
Yeah.
and keep it in the list. So with open members.txt, what we did in here, we opened it, right? For line in a file. What is a file? Is an object of file, right? What does it have? Lines. So the first time we run the for statement, for line, this is which line?
First time.
Line 0. The second time, line 1, line 2. So now what we have in the line, what is stored in the line? The first line of the file. Clear?
It's clear, but what I see here is like you're assigning an empty line to line. Then you-
File. This is a file, in the file. Line in the file. So for line in the file. So let's do it like this. So this is the file in here. This is the file, right? I did open it. It's open, right? And I have created an empty list. Where is the empty list? Let's put the empty list in here. Members, right? What is it? Members, right? Right? So now we're gonna come where? To for line. What is the first line? Line, this line. The line equals to what now? To the first line in here, which equals to this one. Equals to what? Abu Znaid Shakur 92, I think. Right? So that's the first line. That's what's saved in the first line in the file, which is there in the file. And then after what we did, okay, we removed from the line. It has it at the end in here. What does it have? \n. So in the replace, what we did, we removed the \n. So this was removed. I'll tell you why in a second.
Okay.
All right? It was removed, right?
Remove just the backslash.
Huh?
Okay. I was thinking it's removing the whole line. That's
No,
why.
removing, just replacing the new line with empty, right? Then after that, what we are doing in here, members, what is members?
Empty list.
It's a list. And appending to it is what? Line. What is line? This one. See this in here? Actually, with the commas. We'll go where? Here. We go inside the list, right? Then it's gonna go. Let's say the file has only 2 lines. Then now it circles back in the line what we have, the second line, and then add it where? Here, the second one, right? So I took the lines from the file, removed the end of the line, and I added to where? To the list. I don't need the end of the line in the list, right? I don't need it, right? Right, okay? So in the list, okay? And then when I printed it, so this file has how many lines? 2. If it has 5 lines, how many I will have?
5 lines.
Clear? Yeah. By the way, when you get confused, is clear for you? Clear? Okay, anybody? Okay. So please, if anything you don't understand, stop me. All right? We don't have to finish the whole presentation. If I have like 100 slides, I'd rather finish 50, you understand them, and you do the 50 by yourself, rather than going over and you don't understand. So stop me always, okay, please. All right? And there's some things you can ask me, I say that no, there's nothing wrong with it, okay? But stop me, okay? All right.
Professor,
Yes.
why didn't you mention the second time with open members.txt as read? We are reading it, so will it throw an error there? Because it's not mentioned that we are reading.
It should be as read, so I think there's a typo in here. Always you have to specify how you are opening it. So I think it's missing the mode. Okay?
And what if we have a huge page and if we just do a read line, won't it crash? Basically, we need a buffer to store, right? We can't like read the entire page.
You could. I mean, remember that you're having like now computers having a 32 gig could read thousands of lines. Okay, I mean this is nothing. This is just a text. Okay, nothing. But let's say that the memory is so low in your computer, then you are out of memory. That's of course there is a problem. All right. How to write and read a list. Okay, so in here, numbers, the same thing. What is the difference in here that we have? Only numbers. Okay, so just follow through it. Okay, numbers, not, okay. So this is a program I need you to follow, okay. It has this program, it's like what we did before. So it has a command line, all right? List all movies, add a movie, delete a movie, edit, okay? Or exit, right? So when you enter, for example, the command list in here, okay, what does it do? List all the 3 movies you have, all right? Command add, you could add a movie. Remove, you could remove a movie, etc., etc., delete a movie, right? What is the difference from the program you did last week? Last week, the data is saved where? Hard-coded in where? In the program, okay? Right? So if you add like movies and all of that now, once you reset the program, is gone. In here, where is it coming from? We're reading it from a file, all right? In the future, it will be coming from where? Database. And I put all the files for you. You could try them. Okay. Did you see the files in the PowerPoint? Did you try? Everybody tried all the programs, or just you took it easy?
What do you mean, tried all the programs?
Huh?
What do you mean by you tried all the?
I mean, run them.
Oh, no.
You did not run them?
No.
Okay, that's a big problem. Actually, running them is not enough too. You have to write them. Seriously. I mean, you can't imagine how much mistakes you do when you write a program. Simple mistake when you start debug. And sometimes, like, your eyes get crossed and you can't find what is the problem. Small problem. Okay? So that's the experience that you need to do. Please try to do as much as you can. Alright? Alright, so let's go quickly over this. So that's the file where we save the data. Alright? So this is write a movie, a function to write a movie, function to read a movie, okay, and to display. Anyways, let's take a look at write. That's what we were doing, right? So this is the file, and we open it because we're writing. It's in writing mode, all right? For movie in movies, then we write to it, and then here we append to it, and so on and so forth. So take a look at it like before. The only difference now, we are dealing with files. We're reading to a file and writing to a file. All right. The writer function to CSV. So what is CSV? It's a comma separated values. Most of the files are like that. So for that to be able to use it, okay, you have to include a module called CSV. CSV. Just all you have to do, import it, all right? And you don't use write and read like we did before, but you have to use write rows, okay, write rows, and you write the rows in there. So let's pretend that we have 2-dimensional list. Call it list of lists, 2-dimensional list, as you see in here. This is in here. What does it have? The movie and the year, for example, right? So it's like, what is the size of this list? It's like 3 times 2, right? All right. So how to import? Very simple. You have to import the CSV, and then after that, to deal with it, what you say, open, okay, write, and always you say new line in here. That's the end of it and the file. And to write to it, you have to use writer, not write. There is R at the end. Okay? Or you could use write rows to it. Right? Try it out. Same thing with read. Okay, we don't say read, it's reader. So when you're dealing with CSV values, there is a method called reader. Alright? So you open it, and when you read the so CVS dot reader file. Reader file. There is a lot of arguments, optional arguments that can be used to change the CSV. So by default, the CSV is separated by comma. Can you change it to a tab? Yes. So there is a delimiter. All you have to say, for example, reader, CSV, reader, file, and you change the delimiter. Use the value. Remember what I told you, and this is very important to always watch this out. That we have methods, right? We have methods, and we have functions, right? So usually, for example, let's say we have a method. Let's call the method is method 1, right? Let's say method 1. So for method 1, you're gonna have what you're gonna pass to it? Parameters. You're gonna pass parameters. Okay. So many times, okay, we don't pass parameters. Why? Because we use the default value. So usually, for example, we have parameter 1. Okay. Parameter 1 equals and default value 1. Parameter 2 equals default value 2, and so on and so forth. Okay, and usually you see the square bracket around that in the manual. What does it mean, a square bracket? What does it mean?
List.
It's optional. It's optional, right? And what does it mean, a default value? There is a default value. So always when you're using a method, always have a screen next to you that it gives you the data sheet of the method. Because sometimes you need to use it in a certain way instead of writing a very long code. It's available for you as a parameter you pass and you do it, okay? All right, so you could change that, right? The same program here, but in here what we are dealing with, and here let me show you the program, we're dealing with CFS file, comma separated file, the same code, take a look at it, and it's available for you. Now the last thing, we're going to talk about binary files. So binary files, we have to include a module called pickle. Pickle. So we spoke about regular files. Do we have to include module? No. We spoke about CSV files. Do we have to include module? Yes.
Yes.
What is a module?
Import CSV.
Okay. Now binary files. Do we have to import a module? Pickle. Okay. And we have two commands: dump to write and load to read. Dump and load. We don't use read and write like the first one. We don't use reader and writer like the second one. We use dump and load. Dump and load. Binary, right? Same thing. The only thing different commands. Okay, so let's take this example. This is a list, right? So first of all, you have to import the pickle and you have to open it. Small difference. When you open it, you have to say WP. What is WP?
Write binary.
Write binary. Write binary. And another difference, we don't say write, what we say?
Dump.
We say dump to write in all of that. Anything else, it will be the same. All right? In B, that's it. To read from a binary, we don't say read. What we say?
Load.
Load. And when we open it, what's the mode? RB. Read binary. Read binary. It's very important. And the same program, you could try it out. Okay, and let's have a break for 10 minutes. Thank you. All right, so moving on. Okay, so now we're going to talk about a very important topic. Okay, when you write your code, you will have errors, right? What kind of errors you can have?
Syntax error.
Which is like compilation error.
Mhm.
You discover and then compilation. We don't have compiler here, interpreter, but that's fine. If it's a C code or C++ code, you cannot even run the code until you fix all the syntax, right? It has to be perfect, all of it. In here, you could run it line by line, okay, but again, you'll discover the problems at the compilation time or interpreter time, all right? And this is the easiest kind of error. Why? Because the language error, you'll know it and you'll fix it, right? So what other two errors you could have? What? Runtime error, which is the most dangerous one. Is the most dangerous one. Okay, why is it dangerous? Because it will destroy your application. It will halt your application. Give me example for runtime error.
Divide by 0.
Division by 0. Division by 0 is not allowed. It's not allowed at all. So division by 0, that will halt your system completely, right? So this is a big thing. All right. So what the system does when there is division by 0, it will issue an exception. And will halt. All right. So we have to take care of this issue in our program. So as an example, right? As an example. If, for example, I have a program that it tells me input, you know what's input, right? Okay, enter a value X, right? And there is another input, enter a value Y, right? And then I'm calculating Z equals to what? To X divided by Y, right? So if the person enters here 5, and then he enters 5, is there a problem? There is no problem. 5 divided by 5 is 1, will give you the result. But what if the person in here enters 0? So what you have now? Division by 0. All right? This is, you can discover it only in runtime, because you don't know what is what the person will enter, right? The person does not know how the program works. Runtime problem is good. So what you have to do, you have to write your code in a way it will handle all possible runtime errors. That's your job. All right? That's your job. Can you imagine, for example, this code runs off a server, and then all of a sudden you have a server that serves like 5,000 people, has to restart. It has to be taken care of. Okay? So buggy code like that is not acceptable. So what you have to do, very simple. You put it inside a try. So you say try. And and then you have accept. Okay? So what you'll do, you'll put this inside the try. Of course, you have to indent. So you say try z equals x divided by y. If this raises an exception like division by z, the error will be division. Let's say I forgot the name, division by 0, let's say. So if a division by 0 happens, all right, the system will issue a division by 0 exception. So this will move right away. It will not finish the sentences, the rest of the sentences in here. It will jump to where? To the except. And the except, for example, what you could say, okay, print, you must give integer for y, for example. And the system will not crash it. It will not crash. So try except. Try. Okay. Let's say that somebody entered, the user entered here 5 and then here 5. What will happen after that? After this executed? After this executed, what will happen?
Nothing.
It will jump here after the exception. All right? If there is an exception, all of these will be cancelled and will jump where? To the exception. And then will quit. Will quit the execution. All right? You got it? All right. So what will happen? What will happen if there is multiple errors could happen? You could have multiple exceptions. So for example, you put another except in here. You could have another except. Whatever the value, another except, another value. So if this exception happens, it will go to this. If another except happens, it will execute the sentences in here. If a different kind of exception, it will go in here. All right? So you could have multiple kinds of exceptions. Right? And these are built-in exceptions in the system. I'll show you in a second. All right? So here is the news for you. The news. From now on, there is no homework submitted without handling the exception. So for example, in your homework, if you know that there is a division, you have to handle the exception for the division. If there is like iteration and there is exception out of the range, you have to handle. So basically, all your code has to have try except to handle everything. All right. And this is to handle what kind of problems? Runtime. What is the third type of exceptions that you need to handle, or problems you could have? Huh? Logic errors. Logic error. What is the logic errors, for example? So, for example, your logic error says y must be greater than 10. So let's say in this person, instead of entering 10, he entered 3. So 5 divided by 3, is there a problem with the system? Will it raise an exception for you, the system? No. But for your logic, is it good or not good? It's not good, because the minimum amount for y is 10. So yourself, okay, you can raise an exception if the user enters less than 10. So there is something called raise exception. You raise it. You raise the exception. Okay? And that's for your own logic. So what we have learned so far, that there's exceptions happening by the system. Okay, once they happen, okay, if you don't have try and except box, the program will crash, right? So always critical codes that could raise an exception, you have to put it in the try. And to handle the exception in the except. That's what we learned. Number 2, we learned you could have multiple blocks of except. So you could have each one handle different kind of except. Right? Number 3, okay, you could, for your own logic, raise an exception. Even if the system does not raise it, you could raise it. Using what? Raise. Raise, okay, exception. Number 4, there is a sentence called finally. So there is try, except as much as you want, and there's something called finally. What is finally does? Whatever in the block file will be executed once, regardless if you went through exception or not. So what we use finally for? For a cleanup. For a cleanup. Example. I'll give you an example. Let's say that in here we open the file. We open the file. What we should do after we open the file? At the end of opening the file.
Close it.
Close it. So let's say here you're reading, writing to it and all of this. You could keep the closing where? Finally, close this file. So could you use it to be executed once after all the exceptions. Whether you went through the try, whether you went through the try or through the exceptions, will be executed once. So how many commands we learned so far? Try. Except.
Raise.
Another except. Another except. Raise.
And
Finally. So how many total?
5. Oh, sorry.
4. Let me count again. Try, colon, accept, colon, raise, colon, finally, colon. Okay? 4, right? And you could have multiple exceptions. Okay. Now the question is, what are the system exceptions? What are the? We're gonna take a look at them, and there is a rule for them. We're gonna teach you the rule how to use them. Clear so far?
Yep.
Clear? All right. And from now on, all your code has to be immune against runtime errors and logic errors. How we do that? By using try exception blocks. Try exception blocks. All right? Clear?
Can you turn the mic on?
Right? So you have to be, you have to take care of that. Okay? All right. Any questions? Let's take a few examples in here. So in here, for example, that's example I already mentioned, right? So number, integer. I'm supposed to have integer, right? Somebody enters 5, as you see in here. Is there any problem? There's no problem. You entered the valid integer. Somebody gave you 5 in here. Did the user do any mistake? You asked him enter a number. He wrote 5. It's your fault. You have to handle it, right? Okay? So it will give you an exception. And the exception, it looks always like that. Take a look in here. It tells you the trace back. All right? Start with trace back. Then the file, which is the current file you worked on, or what happened, the exception. Then it tells you the number. And the most important thing is which here. So what kind of exception I have in here? Value error. So usually every exception in the system has a name and the number. Usually it gives you the name, value error, and give you a little explanation in here, okay, that in it with invalid literal for in it. So that's not integer. That's not an integer. So in here, what kind of error was raised? Again, what's the name of that exception? Value error. So of course you could have functions could cause a lot of anyways. So what the solution, as we said in here, what you have to have? Try, except, okay. And for the except, you're gonna give the exception name. In our example, what was? Value error. Value error. Alright? So you put the value error inside this bracket and then the statements. Let's take a look. That's how we did it. So what we did, very simple. Try, and then I put the code inside the try block. So number, input, and then convert it to integer. Print, you enter the valid integer, okay, and okay. Now, if the person enters, let's say, a text, what will happen?
And
It will exit. If he enters a normal 5, for example. So this line will be executed, this line will be executed, and then it goes from here to where? From here it goes to the print in here. But if he enters or she enters text, for example, instead of integer, it will go where? To the exception. So it will go exception value error. Who gonna issue the value error exception? The system itself. All right? The system will catch it, then it will execute this block in here. This block, what does this block says? Print, you entered invalid integer. Please try again. So take a look at the example in here. If you take a look at the example in here, for example, the person entered 5, all right? So which block executed? The one inside the try. If the person entered invalid, which block will be executed? The one inside the except. Clear? So clear? And that's what you will do within all your code from now on. All right? I ask you to do 2 things, and I will never, Shashank, you're listening to me, right? You're listening to this. 2 things. You are not forgiven at all.
comments.
All right? Comments. When you write a code, you have to take this habit. You are writing a story. So for comments, you could have 3 multiple lines comments, and you could have, line comments. And part of the comments is choosing the name of the variables, the name of the classes, the name of the functions. They have to be representative. So then to create, for example, a diff, okay, and you call it XYZ. What's XYZ? All right? So I need to read a story. When you write a code, I need to go like a story. If you give it to somebody, okay, we'll be able to read it. I cannot forgive you for that. That's one thing. Number 2, not handling exceptions. So you have to handling exceptions, whether it's a logic exception or runtime exception, or of course, if it's compiler time, that will be definitely fixed. All right. So any code you write from now on, it has to be there. And I need you to get to this habit that you don't write a code in 1 minute and go. Okay, you have to write a code like a story, that when you go to it, back to it, in 1 year, you know what you were doing, okay? All right. And Shashank, for that, you need, take, a lot of points for that. We'll talk about that. All right. I'd rather you write a simple code, perfect code, it does the job, and it looks very good, it shows the good manners that you have as a programmer, than writing like a complex code that I cannot understand, or you cannot yourself. You sleep, and you go to the bedtime, you wake in the morning. What is this? What I was doing, and all of that, you really forget and all of that, okay? All right? So it's not a good habit, it's not good. So we have to build a very good habits, right? All right. So console for a valid integer. So enter, okay, same thing in here. Okay, we already saw that. All right. We already saw that. All right, so this is the application. You can take a look at it. So enterprise, he entered 10. So what happened in here? It went to the exception. It did not crash the program, did not do anything, because I have exception. So I told it, please try again. He tried again, he wrote 9.99. It was perfect, he entered. Then it told him, enter the quantity. The quantity was how much? 2.5. Is there a quantity 2.5? Okay, should be integer, right? So it told him invalid integer, please enter again. Okay, so the first entry has to be a decimal value. The second one has to be integer value. And your system, okay, and then calculated the whole invoice for you. So that's what, so if you have, for example, part of your entry that somebody has to enter email address. So what you have to put it inside the try, what you have to check for? It has to have at least 3 parts, something, it has to have the @ sign, something, dot something, right? At least 3, right? It could be much more complex, of course, but you have to have a dot and you have to have the @ right? Or if you need to make it much more complex, dot should be .com, .edu, the 7 different options. Maybe you create a list to make sure n, so the last it has to be n. If somebody tells you, for example, Abusnaid at my house at go home, okay, is it a valid email address? It's not a valid email address. It has to be inside your. How about the phone number? So the phone number, how many numbers should be? Right, 3 plus 3 plus 4, right? All right. I'm not talking about the shape. At least the number of digits there, right? How it will be entered. Date of birth, okay? So when you enter it, okay, if somebody enter like 20 digits for date of birth, okay, DOB, what are you gonna do with that? You try and check, right? So you have to validate any number, you have to validate anything you have to enter, validate. What other validation? Opening a file. So what is the first thing you have to make sure? The file existing. All right, the file existing. If it's not existing, okay, should have an exception. All right, writing to a file. You have to make sure, if possible, I think with sys, when you include sys, if it's writable, it's not write protected. Okay, you have to. Okay, what other exceptions you could have? Iteration. So iterate. So for example, if you need to iterate through a list, what is the first thing you have to do? You have to know the length of the list. So if the length is 10 and you iterate for 20, what will give you an 11? Exception. You cannot iterate, okay? And that because it's more, it's not iteration, right? Loop, you cannot loop. So you have to check for many things. So the way what I need you to do. So we already saw that. So the hierarchy, I need you to take a look at the hierarchy for the exception. So usually there is a hierarchy. The exception has inside it OS error and inside it value error. All right. Inside the OS error there is file extension and file not found error and many other. So take a look in here. If you take a look in here, all right. And I give you the link, you could go to the link, you could learn more about it. So as you look in here, there is a base extension. From that, you're going to have exception, and you have keyboard interrupted, right? From the exception, you could have many sub-exceptions. For example, the one we looked at is what? So for example, attribute error in here, which is arithmetic error, all right? So we went to, which one we tried? Zero division error. Zero division error, which is a subclass of arithmetic error, which is subclass of exception. So if you use any of these exceptions, it will catch what? Division by zero. Division by zero. It will catch, why? Because it's subclass. So if my goal is to catch up division by zero, I could use division by zero exception, or I could the parent, arithmetic error, or I could do the exception. All right? Now, when I list multiple exceptions, remember we said you could have try, right? You try, except. So the last one has to be the most general. So in this one, which one is the most general? Huh? The exception is the most general. Then the arithmetic error. Then division by zero. All right? Can't be the reverse. All right? So the most special one comes on top, and the most general one comes in the bottom. So this is just a sample of the exception. So for example, in the exception, we have how many sub-exceptions? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? So for example, we have lookup error. In the lookup error, you could have index error or key error. How about the files? You look at the files in here, OS error, you could file exists error or permission error. The file is not writable. You try to write the file is not writable. So you have to raise an exception. You have to look for all the exceptions. All right? So to look at all the exceptions, built-in exceptions in the system, in Python, I provided you the link there. You go there. Okay? And I'll show it to you in a second. So if you go in here, that's what it is. All right? It's not clear. in here. So the accept clauses must be coded in sequence starting with the most specific exception, okay, and goes to the end. So maybe what I could do, let me go in here. Why? Okay, so if you go in here, okay, so you see the exception hierarchy. The most important is the exception. You see the exception, and these are the sub-exceptions. So, for example, if we're gonna talk about the most common one, OS error. Also it has sub-exceptions, such as, okay, blocking, I/O error, child process error, connection error. Okay, in connection error it has sub-connections. Let's go down. For example, we have what is division by zero? Zero division error. So it's coming from arithmetic error. Inside arithmetic error exception, there is floating point error, there is overflow error, there is zero division error. So basically, if there is anywhere in your program that you're going to have a division, which exception you have to handle? Always. Division by, zero by division. If you have like something that has extensive use for the memory, which exception you have to handle? All right. If you don't want to go that detail, you could go for the mother one, for the parent one, arithmetic error. So it will handle all of these in here. You got it? Okay. So we said you have try, except, and you could have multiple exceptions. So as you see in here, so for example in here the file name, okay, trying to enter the file name. So in the so what you're trying to do, open the file name in here, all right, and the first exception you're trying to handle is what? File not found error. Then OS error. So the file not found error is part of OS error. That's good. OS error is part of the exception. I could remove all of these, by the way. I could remove all of these in here. I could remove them, and I keep only this. Is there a problem? Will I be able to catch the error? Yes, because exception is the parent and will catch all the sub-parent exceptions. But I will not be specific in my program. I will not be specific, right? Clear to this point? This point is clear? So if I remove the first two exceptions, will I still capture the exception? Yes. Yes, I will be able, all right? Because the exception is the father of the OSI error, or the parent of the OSI error, and is also the parent of the file not found error. Clear? So this sequence is very important, all right? So if you can have details, if you have a clue what kind of exception you have, you could put that. All right. Sometimes you need through the program to exit. So all you have to import sysmodule and you could exit. You could exit. So for example in here, sysexit. When the exception has happened, I don't want to do anything. I want to exit the program nicely and smoothly. All right. Why I have to exit the program nicely and smoothly? Because when you exit, usually you clear the memory, you know, right? Because the program is going to use a lot of the memory. If you crash the program, the memory will be occupied and the computer will get slow and the memory is not released. Part of any program you do, okay, that you use the memory. But before you quit, what you have to do? Release the memory. If your program does not do that, what will do? Will cause memory leak. then the memories cannot be used by other applications. All right? Then you have a buggy program, then nobody will buy your program. All right? If they buy it, they'll sue you, okay? Because it's like causing you trouble. So writing a code does the job is one thing, but work perfectly is a whole different thing. Okay, sometimes you have to work in the fixing the code and make sure it's perfect much more than time than creating the code itself. All right. So again, I will repeat: comments is very important. Try exception is very important, and you have to learn how to do it very well. Okay. In interviews, when they ask you to write a code, they want to see you how to write these. If you are lazy, you just have one exception. You have the parent, you'll catch. But if you are very detailed and you understand what you're doing, you know what are the possible exceptions. So there is a division in this try. If there's a division, that means what? It's possible for division by 0. And then you handle it as it is, right? So be careful with that and all that. Okay. So, anyways. And this is a program, you could try it. All right, try, except, and there is something called finally. So what does finally do? Again, execute one time at the end. You could use it for cleaning the system. So let's take an example in here. So look in here. So you are reading from a file. You are reading from a file. So what you have to do, you have to open the file. All right? In here, it will close automatically because you are using with. There is no problem. But look in here. You open the file without with. There is no with. Right? So you do whatever you want, but at the finally, what you do? You close the file. You could do whatever in the finally. You could print the result. You could do whatever. Finally will be executed once, whether you went through try only or with the exception. It will be executed once. All right? So now we're going to talk about the fourth thing is raise exception. So you could raise an exception. Very simple. That's how you raise it. Raise. You give it exception name and the message. All right. So raising a value error, for example, if you need to raise a final, so raise value error. Okay, invalid value. Again, value error like what? For example, your code, your logic says y must be 10 or greater. All right. So you could raise a value by yourself. The system will not raise it for you because there's nothing wrong with it in the system. There's nothing wrong to it in the system, right? It's exactly like your wife buying a couch, okay? And she ordered like a brown couch, and you get a gray couch. Is it a mistake? Is it a mistake for the store? For me, myself, gray like brown for me. For my wife, it's a big mistake. So she has to raise her exception. Shh, take it out. Take it out. Okay, the color is not right. Okay, so it's a logical one. Okay, that's your logic. Okay, so always you try to do, and it will help you when you write a big code, thousands of lines. All right, then if you don't take care of all of these things, and there's a problem here or there, go figure out. But if every single line you write, you are raising and evaluating what problems can happen, and you handle them right there. So even if there is some problem, there is a way to know where is the problem. You're not, in real life, you're not writing a code that's 5 lines, or 20 lines, or 50 lines, or 100 lines. Usually like hundreds of lines, or thousands of lines, right? So this is a very important thing for you. One more thing, I added for you today, actually, in here, that you could also log. You could have a log. You know what's a log, right? So nowadays, for example, when you have an application installed in your computer, there's a problem. You call the tech support. What does the tech support tell you? Tell you there's a log file, somewhere, send it to us. So you could log your program. When there is an error or anything, it will be saved in a file. So to collect all the data. And so in here, for example, raise a value error, all right? And, where is it? It's not here. It's not this one. In here, logging an exception and raising it for calling. So you are opening a file, all right? you're doing whatever you want to do, and then you are raising an exception, and you enable the log exception. So the log exception will save it to the log file. All right. So for the next assignment, there's two things I need you to do. So check. There's two things they need to do. Is the comments and the exception. And one thing I need you to do is once in any assignment for this week, like you can have 5 problems or 1 problem, I need to have the logging, the log. So you add the log to the program. So that means when there is an exception, it will be saved in the log file. Clear? At least once I need to use it. Okay? The log file. Okay, what's the log file? What's the log file?
It's a place where the exception stores.
Where the exceptions messages are saved, a file. Okay, where there's a problems in the code, right? All the systems have log files. You know what's log files, right? So log files, whenever there's a problems, these problems saved somewhere. So when you call the tech support person, the first thing does is look at the log, right? So please try the log. I provided you the link for it. Okay, I think in here. Okay, there's a link for it. Take a look at the link and make sure at one program you use the log file. Anyways, so final thing I want to talk about recursion or algorithms. All right. So usually when you write a code, you could write it in 2 ways, right? You could write it as what? As loop or as recursion. What is recursion? Function calling itself. The function calling itself. So let's take a look at this application here, the first one, display message. Okay, while a true print, press Ctrl+C to stop. So this is by iteration. Keep rotating forever until you hit Ctrl+C. Okay, this is iteration. The second one, okay, and this is will create how many image of the application in the memory in the stack? One, right? It will create it's one application in the stack. The other way of doing it is by having the recursion. Look in here what I'm doing. So there is a function called display message, and then printing Ctrl+C to stop. Then I'm calling the function. So the function is calling itself. So every time the function calling itself, the stack will have one more function. You're going to keep rotating forever until you have the base condition. In the base condition, it will quit the function, will go to the previous function, okay, and then to the next function until the end, okay. So the question is, which one you think is more efficient? Iteration or the recursion? Recursion is more efficient. Any other opinion? Can you read the blue box there? So each time a recursion or recursive function calls itself, Python adds the function call to the stack, which is the list of the function calls that are waiting to be called in the reverse order in which they are, not here, are called, which are called. So instead of having one image of the function, we have so many images. So definitely iterative is much more efficient on the memory. It's much more efficient in the memory than recursion functions. So the question is, so look in here for example. So let's say that we're going to have a function to add a number. To add, so if we have 5, we need to add 5 plus 4 plus 3 plus 2 plus 1 plus 0. We could do it in 2 ways. We could do it in an iterative way, like this in here. So what I did, total equals 0 for number in the range, upper plus 1. Why is it upper plus 1? Because range starts from where? From 0. So if I need to calculate it for 5, okay, so this will range from 0 to 5. 0 to 5, right? So every time I iterate, I add to the total the number, right? I add the number to the total until the end, right? So I will add 5, then 5 plus 4 plus 3 plus 2 until 9. This is the rotation. I could write it in recursive. In recursive, what we did, we created the add members, and we have to have a base condition. What is the base condition? 0. If the upper equals to 0, stop. Quit. Right? If the upper equals to 0, quit. So what will happen in here? At the beginning, what is the upper value?
Whatever the user.
What is the upper value? Let's say for 5. Let's say for 5, right? Let's say for 5, right? So the upper value is 5. Is upper equals 0? No. Return upper. If it's return upper if it's 0, it's not. So it's gonna go to else. Else upper.
5 plus
Okay, which
5
is
minus 1. That is 5
which
into
5.
4.
And we calculate the upper 4 now, right? Then it's gonna go up there.
Then
In here, and calculate it 4, and then 3. So it will be 5 plus 4 plus 3 plus, right? So every time we call it until it comes to the base. What is the base? Upper equals 0, then it stops. Stops. Alright, so this does the job and that does the job. What's the difference? The difference that every time we call the recursion, it will create an entry in the stack. Entry in the stack for the function. Another example is calculating factorial. What is factorial? Factorial 5 equals
5 into 4.
5
into
times
0.
4 times 3 times 2 times 1. Alright? And what is the base condition? Factorial of 0 is 1.
1.
So that's where I end, right? So look at the code. How simple is the code could be?
Return 1.
If n equals to 0, return to 1. That's the base condition. If n greater than 0, return n multiplied by n minus 1 factorial. That's a true factorial. Okay? Until we have factorial 0, we stop. So to calculate the factorial is only 2 lines. 2 lines, right? So if I'm doing factorial for 5, so how many functions I will have in the stack? 5. To be called, the function will be called 5 times. If I'm calculating factorial for 100, how many times will the function will be called? 100. So it's increasing linearly, right? Is that good? It's not good, right? It's not that good. Let's take one more example. So as you see in here, it's taking as much. So in Python, an iterative solution almost always runs faster and uses less memory. However, for some problems, a recursive solution may be more apparent and easier code. Why we use recursion? Because sometimes it's much easier code, okay? But iterative usually is much more faster, Depends. So it's linear, right? Linear, that's the complexity. So did you hear about Fibonacci series? Fibonacci series that, you add here, look in here. You add 0 plus 1, give you 1. 1 plus 1, give you 2. So you add the previous 2 and you add them. So 0 plus 1, 1. 1 plus 1, 2. Then 1 plus 2 gives you 3. Series, right? 2 plus 3, 5 until the end, right? So if we write that using the iteration, how are we going to write it? Using the iteration. So what we'll do during the iteration, what is the base? The base, if n equals 0, return 0. If n equals 1, return 1. These 2 bases, okay? And to calculate it, how many times we have to call the function? Twice in every. So we're going to call fib n minus 1 and plus fib minus 2. For every iteration, how much we are calling? Twice, not one time. So this problem becoming what? Exponential, very expensive. Because you have to call twice for every iteration. Not good. Not good in memory, right? All right? Not good. All right? So if you need this take example in here, so if I need to calculate fib 5, what does it mean? I need to calculate for the first 5 elements. So it will be 0 plus 1, and then 1, 1 plus 1, 2. This is how many? 4, right? 0, 1, 1, 2. Then 1 plus 2, 3, right? So if I need to calculate it to 5, so 0, 1, 1, 2, 3. So up to 3, right? Up to 3. So what we'll do in here, so what you'll have, you have to calculate fib 0 plus fib 1. Fib 1 gonna go in here, and this will be fib 2. Fib 2 plus fib 1 gives fib 3, and then, you know, the fib 4, and okay. So every time, and then at the end you have to add fib 3, the fib 4 gives you fib 5. So you have to run it, okay, twice. This will give you exceptional, exponential complexity, and this will make it very uncomplex, not very complex. It's not reasonable, right? So have you done the Towers of Hanoi before? Anybody done the Towers of Hanoi? All right, I'm sure anybody did programming before. What we use for it? Recursion. Do you know how it works?
Yeah, you have to take the thing and then you put it on top.
So basically we have 3 pegs. The stick is big, and we have what they call it a disk, right? So we need to move the disks from A to C. But there's a conditions. Okay, condition. You cannot move more than 1 disk at one time, and you cannot put bigger disk on top of the smaller disk. Right? So look at the steps how we do it in here. Okay? Let me do it from here. Okay? So again, the conditions that we have 3 disks, we need to move them to C, from A to C, from A to C. All right? But you know, I cannot move more than 1 disk at one time. So I cannot carry 2 and move them. I cannot. All right? And I cannot put a bigger one on top of a smaller one. All right? So what is the procedure in here? What we did, first of all, we take the small one in here, we move it to where? To C. Then I take the blue in here, I put it in here. Right? So now I have the A, B, C, each one have 1. Then what I do, I take the C, this one, I put it here. Then I take the big one in here, I put it here. Right? Now, the yellow, I cannot put it, the yellow, okay, if I put it on top of this, does not work because it's not in order. So I bring it back to where? To A. So now C, B, and A. Then what I do, I take the yellow and I put it here. And the blue, I put it here. Then I take the yellow and I put it on top of it. Right? That's the algorithm, right? Clear, right? So we need to write a code for it. And the number of pegs always how much? 3. The number of desks, or you know, the desk could be any number. It could be any number. It could be any number. So what we are doing is a clear algorithm. Everybody understand? I could repeat. Everybody understand the algorithm? Okay. It's a very famous problem, right? So these are the rules. So basically, what we have to do, okay, we have to move the disk in. What is n? The number of disks, right? And the source, which is A, to the destination. What is destination? C. And what is temporary is B. If n equals to 0, if the number of disks are 0, then that's the base situation correct. Otherwise, what we're gonna do now? We're gonna move n minus 1. So if I'm moving three disks, n minus 1 becomes how much? 2. Same thing. Then one more time, n minus 1 becomes 1, and it's like rotating. Okay, just so when you execute it in here, okay, look at it's exactly the same logic. So what we did in here, look at the first line. Move disk 1. Okay, what is disk 1? The smallest one, right? The top one. 2 from A to B, and this 2 from A to C, and then you move disk 1 again from B to C, and so on and so forth until the end. Let's run it for fun. That's a code. Let's try to run it. All right, this is the program, and I will run it, okay? So I'm gonna run it in here. So enter the number of disks. How much number of disks you need?
How many?
How many?
3. 3.
Easy, right? Give us, okay. How about, let's run it again. And we use 10. Easy, right? All right. So what is one of the problems? So the problems in recursion? The depth of the recursion. Because of the memory, for example, in the Python, the maximum it allows how much? 1,000. How many times we call every time in this algorithm? Twice. So let's call it for 100 times. All right. So in the first class, I tried it for 500. It never ended. It takes forever. Okay, forever. I'm not sure how long it's gonna take in here. So that's why we have to worry about the algorithm we are using. Most of the applications we write are for real-time applications, right? Real-time applications. So many things, you could do it in different ways. Like for example, if you like to do sorting, how many algorithms for sorting?
A lot of.
Not many, right? But there's some ones are faster than the others. Some ones are faster for certain kind of data or type of data, and so on and so forth. So I could give you a problem. You write it in a certain way, the other person writes it in a different way. What matters at the end, few things. Of course, the code has to run, it has to do the job, etc. But also the speed, the algorithm. What is the complexity? Anybody done algorithms before? No? Do you know what's the complexity of the algorithm? So for example, if you have complexity of see, it's still running, okay? So if you have complexity of O1, that's the best thing, all right? If the complexity as On, that means it takes more time as n grows, all right? Okay, how about if it's like On squared? So it will grow, right, okay? Exponential, right? It becomes worse if it's, right? If it's, for example, O n ln n, for example, it will be less. So the complexity is a very big issue of the algorithm that we are writing. Okay? It will take simple program now, simple program, just sorting for 100 disks until now it's not done. All right. So I mean, usually in your programs, when you write the code in no time, it's you see the output. In the research for people working in machine, anybody did machine learning, deep learning here? All right, deep learning, machine learning. So how many days you stay running the code?
I executed one neural network for 3 days.
3 days. Sometimes for 3 weeks. Okay, maybe 1 year. I don't know if it can survive, right? Okay, it keep running, right? That's why, you know, we need like high GPUs. We don't use CPUs for running. It needs a lot of power. It needs a lot of memory, right? So the algorithm, how is the algorithm? So you have to think that in real life, the algorithms and the application we're running is not as simple as we're writing, you know, in your assignments and a simple thing. It will take very intensive. If we have time during this class, we're going to talk a little bit about machine learning and deep learning and all of that. Okay? So you'll see that, you know, you're dealing, for example, with maybe thousands of records that you get to process. Right? And the way you write the algorithm, the way the complexity of that algorithm is, it will make a difference of your application. All right? So I'm sure that I could have a dinner and come and until not finished, right? And what's happening now? Function is calling function. Every iteration, how many functions are called? Twice. All right. So can you imagine writing recursive functions, you know, for much bigger things than this, and takes forever, right? So you have to think always in how to write the code. It's very important to write the code and try to use the most suitable. Finally, before we end the class, okay, I covered what I want to cover. I teach another class called IoT. Anybody knows what IoT? Raise your hand if you know what's IoT. 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 I-O-T. Internet of Things. Okay? It's not I owe you a cup of tea. It's okay. Alright? IoT, Internet of Things, right? Anybody knows what's Internet of Things? It's basically Internet of everything. Everything in the whole world will be connected to the internet. All of the chairs, table, okay, podium, lights, curtains, doors, everything will have an IP and connect to the internet. So for example, this chair, by the end of the day, we're gonna know how many people sat on it, how many minutes it was busy and not busy. Everything will be connected. When you go to the store, you know what's RFID, right? RFID, the tags, okay? These provide a lot of information. All of them are connected to a server that collects the data, all right? Okay, so this is all internet. So basically, they call it Internet of Everything will be connected to the internet, all right? And everything will have a sensor that read the data, read the data, create the data, and the data will be gone where? Somewhere for processing, right? So think about like every item in Macy's or Home Depot, for example, has RFID tag, all right? So RFID tag is connected wirelessly to a reader, and the reader to a server, right? So if somebody moves it out without purchasing, what will happen? Well, what will give a signal, or shout, right? Also, when you look at, to go to Macy's, for example, all right, each shirt, for example, see this nice shirt, it will have RFID, right? So at the end of the day, the owner of the store will know if they have to keep this or not. How can they know? Because if this item is very popular, people will keep touching it. When they keep touching it, what will happen? It vibrates. Okay, then this will say, oh, one person touched it, another person touched it. Oh, this kind of shirt was touched 20 times a day. Keep it in the store. But if you have an item that nobody touched it, nobody moved it, okay, that means it's not very popular. Remove it. Why are you keeping a space? IoT, everything will be connected to IT. All right? So you heard about the Pi, Raspberry Pi?
Yeah.
Okay? So, huh?
Cheap computer.
Yes, it's a cheap computer. It's a powerful computer. All right? So, what language it uses for programming it? Python. It's Python. Okay? So, knowing it, you could program a lot of hardware with Python. So, one class, we're going to have a Raspberry programming. So you're going to bring Raspberry Pis, all right? And we'll teach you how to connect it and how to program it. And how you can write the code in Python to control LEDs, to control motors, to control anything. So from this Raspberry Pi, okay, you could control many things, all right? So this Raspberry Pi, or the Pi, you could connect to your garage door. And because it has a network module, you could control it from where? From your work. You could control your entrance door. So when you're there to delivery, that's the future. The future, you don't be home, you need to be at home for delivery. What will happen? What will happen? That your door is connected, your garage door is connected to IoT device. So when the person is going, the UPS is coming to your home, you know an address is coming. So when he rings the door, it comes in here. Okay, you see it, you see his photo. Okay, you push it from here, you open the door while you're watching. He goes inside the house, He put the stuff, leaves, he closes from here, IoT, everything is connected through your cell phone, IoT, okay, Internet of Things, right? The smart cars, the smart cities, all IoT, right? Alright. So a lot of things. So last semester we were teaching IoT. The students created very good applications. So Neil, what did you do? I forgot.
Oh, I made a smart mirror.
Smart
entire
mirror. So he created a project, smart mirror, that the mirror in the bathroom connect to the internet when he's doing shaving, whatever. It plays music, it plays videos, it gives him the temperature, you know. Maybe if he does not shave very well, tell him, okay, you have to go left or right. Okay, entertain him like smart mirror. It's mirror connected to the internet. Okay, so it could do, okay. There, another group did a project that oil tank in the house, oil tank in the basement, that automatically, you don't have to go and check it.
Alexa.
You automatically check and calls the company and the creator. Everything is automatic. Okay, some other people created, the other group created like tags for the bag. You know, when you come arrive. So what you have to do, you have to wait for the bag. If you're driving domestic, it's easy, right? Because there's not a lot of bags, small airplanes. But if you're coming from China, you know, there's like 600 people in the airplane, 800 people in the airplane. So you have to wait for the bag. Oh, this is my bag. Oh, look. Okay, you hold it, look. It's not that. You wait, okay. So you'll have a device for it and you wait. So when it passes by, okay, have it like that, because it has RFID tag, passes by. You start, you see, yeah, it's coming. Hey, hi. You take your bag. Okay, students, some student group did that project. She did a project with her group, okay, that was a senior project, is AirSense, right? That's what we call it, AirSense. So this is AirSense, that a device, small device, that measure like 5 gases, 5 whatever temperature, whatever thing, all of that, okay? Then you could, you could measure, you have it with you in the bag, and you could, wherever you go, you could know what is the contamination, how is the climate, all right? It's a nice application that we have created, all right? So Raspberry Pi is one of the embedded systems that use Python. We'll try to, we'll try to let you play with it a little bit. But there's a lot of experiment, live experiment we could do next semester in the IT class. Of course, Somail was, he was the GA for that class. Any other questions? All right, so I think we are done, okay? Looking forward to seeing you next week with perfect assignments. Thank you.